Okay, so here are the notes for section 4.5, proving triangles congruent, angle, side, angle, 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 side. This is actually really the exact same thing as 4.4, but now we have two other theorems we're going to use to prove that triangles are congruent. So, yeah, I'll just jump into it. Um, so first of all, angle, side, angle. We already had side, angle, side that had the included side, which meant the side between the two, the angle between the two sides. I'm sorry, we had side, angle, side with the included angle, excuse me. And that had the angle between the two sides. So for side CA and CB, angle C was the included angle. Well, now we're going to have angle, side, angle, and what that has an included side. So you have two angles, angle A and angle C in the drawing. Side AC is the side between them. That's the included side. Okay. So postulate 4.3 says if two angles and the included side of one triangle are congruent to two angles and the included side of the other triangle or another triangle, then the triangles are congruent. So if you have an angle, a side, and an angle. Angle, side, angle. Angle, side, angle. The other postulate, or other theorem, excuse me, is angle, angle, side. And this one we use as well, but this time instead of having included sides or included angles, it's just angle, then a side. An angle, then a side. Okay. Now, the reason that this is a theorem and not a postulate, like the other ones are, is because you can prove this is true, and you really don't even need to have angle, angle, side. You really only need angle, side, angle, but to be honest, angle, side, angle just makes things easier to do. So, here's how angle, angle, side is proven. If you have two angles and a side, well, primarily if you have two pairs of congruent angles, you always have a third pair of angles congruent as well, and they're angle N and angle S by the third angles theorem. So if you have two pairs of angles congruent, you automatically have a third pair of angles congruent, and then you'd have angle, side, angle. So here would be the two angles. Angle N and angle S would be congruent. Okay. And so you'd have your angle, side, angle, angle, side, angle. But what this does, it saves us a step having to go through the issue of doing that. Okay. All right, so here we go. So we've had four different ways to prove that triangles are congruent. We have side, side, side. We can prove all pairs of sides are congruent. We have side, angle, side. We prove that two pairs of sides and the included angle, which is the one between them, is congruent. We have angle, side, angle, where we prove that two pairs of angles and the included side is congruent. And then we have angle, angle, side, where we prove that we have two pairs of angles and another side congruent. And the key to this, for me with angle, side, angle, I probably should have said this, is that if you have an angle and opposite side pair, that's the big clue here. See, angle and opposite side. Angle, opposite side. That's what you want to have. Do you have an angle and a side, and then just any other angle will do it. Okay. So here's what's going to happen, because we're going to really spend a lot more time in class at this on the proofs. We're going to have uh, 6 examples here where you have to, answer why you think it's congruent, which postulate would you use, and why. Okay. So first example pops up now. Okay. Here's the second one. Okay, here's the third one. Okay, here's the fourth one. Here's the fifth one. And here's the last one. Okay, and that's it. We'll spend a lot of time in class tomorrow going through proofs and working these things out together. So I'll see you in class tomorrow.